So now we're going to do number wheels. Number wheels are a beautiful way for children to understand multiply and divide, including remainders. So number wheels and our multiply chart are two different, very different ways of incorporating these understandings. Some children find number wheels much easier to work with than the multiply chart. I have never met a child who didn't enjoy doing number wheels, so we're going to explore this with our number wheel for odd 9. So we have two different ways of looking at multiples. Normally I do the number wheels, which is a circular way of looking at multiples, or should I say in truth a spiral rather than circles, but I haven't managed to do a 3D one as yet, but that's coming. And then the number chart I do later, which is a linear way of looking at the connection of the numbers. So with the number wheels, I like to use cardboard about this size. I buy all different colours because for some children one colour or another is not as harmonious visually as another colour. Some children cannot work with white paper. So I buy all different colours and I ask the children to choose which colour cardboard they'd like. So for me, blue is the most harmonious, so I will start with a blue chart. Now, some children are very good at dividing a circle and other children have got no idea. You say, here's a pizza, can you cut it into 5 pieces? And they'll crisscross cut everywhere. So we have to learn how to cut a circle into nice even pieces. So I use plates and bowls and dishes to draw my circles because we've all got them, whereas we don't all have nice compasses. If you have good compass sets, by all means use them. So we draw our nice big circle. Now, if I were to ask a child to cut this into 5 even pieces, what we would do, we would take odd 5 pebbles, odd 1, odd 3, odd 5, and I would ask the child puts the pebbles on the circumference, to fiddle with them until they're equidistant, because that way we've created 5 even pieces once we do our centre. And so we practice that sort of thing with scrap paper, how to divide a circle into so many pieces. So in order to do a number 9 wheel, 9 is an odd number, so we can't cut the circle straight down the middle. So we have to just do halfway. Now we can either cut it into 3 and then the 3 into 3, or we can take 9 pebbles and do it that way, whichever way the children like. Now, I've divided my circle into 9, I say even pieces, even though we have to not be too pedantic because I've done it with pebbles and so it's not absolutely 100%, but nor will the children's be. And we don't want to pressure the children to have everything perfect. It's not about perfection, it's about understanding. So we've cut it into 9 pieces. Now I say, if I've got nothing, have I got one lot of 9? No. If I've got odd 1, have I got one lot of 9? No. Even 2, have I got one lot of 9? No. And so on. Odd 5, even 6, odd 7, even, I'll try that again, odd 7, even 8, odd 9, yes, we've got one lot of 9. So if I take away one lot of 9, these are the remainders. These are the remainders because I don't have one lot of 9 yet. These are the little leftover bits. So then we can talk about how many remainders there'd be if I divide a circle into odd 7. And we see that we will have even 6 remainders. So if I divide a circle into 16, how many remainders can I have? Up to odd 15. This is important. So we work with the pebbles, with the circles. It's important to understand how many remainders we can have with each divisor. So now we're going to make a home here for our remainders. So I'm using a glass. If you have a compass, as I say, and you can do a better job, that's wonderful. But this will do. Now, I like the children to use colour. So I use a different colour for each circle. So what colour? I will use green for my remainders. So here's the green circle. So I'm going to put my remainders in the first circle. So we've got odd 1, if I've got nothing, have I got one lot of 9? No. If I've got odd 1, even 2, odd 3, even 4, odd 5, even 6, odd 7, even 8. They're my remainders in the centre, as we discovered here. So I've got even 8. And then when I add another pebble, I've got odd 9. So now I have one lot of 9 and no remainders. Well, 9 says to me red. So I want you to use smaller things than this, because ideally we should have 12 circles going out. So I'm just doing it so we can see. So I've got from even 0 to even 8 remainders. Odd 9 is one lot of 9 and no remainder. 0, 1, 2, 3, 4, 5, 6, 7, 8. Odd 9. Even 10. Odd 11. Even 12. Odd 13. Even 14. Odd 15. Even 16. Odd 17, we're all full. So now we need another circle. So I'll draw it by hand. We keep doing our numbers. Even 18, odd 19, even 20, odd 21, even 22, odd 23, even 24, odd 25, even 26. We finished another round of 9s, another one lot of 9s. So now we'll draw another circle so that we have another lot of 9s. So what are we up to? 26, so 27, 28, 29, 30, 31. I think you've got the idea now. So, how does this work? So each time I go around, I've done one lot of 9. So if I say, pick a number, 32, 3 10s and a 2, how many lots of 9? 1 lot, 2 lots, 3 lots, and 5 remainder. How sweet is that? 1, 2, 3, remainder 5. 32 divided by 9 is 3 remainder 5. 28 divided by 9, 2, 3, remainder 1. So this is a multiply and divide by 9 chart, including remainders, which I think is beautiful. Furthermore, we can work on this and invite the children to see patterns. So for example, I call these branches. Let's choose a branch. Let the children choose a branch. So they choose a 3 branch. 3 remainder is the 3 branch. Look at all the numbers in the 3s. Look at their digit sums. 1 and 2 makes 3. 2 and 1 makes 3. 3 and 0 makes 3. So what conclusion can they come to? Every number with a digit sum of 3, when I divide it by 9, will have a 3 remainder. But we can't be sure 100%. We have to check out the other branches. So let them check out the other branches, and they'll see that that pattern is inherent in the nines, which is really beautiful. You can spend a lifetime contemplating all the patterning in odd nine. So this revelation comes from the number wheel in a far more beautiful way than in the linear multiply chart. So we can do our number wheels for even 2. That's very simple. Just cut the circle in half. We can see we've either got a 0 or a 1 remainder. That's it. And we're alternating. We can do odd 3s, and we can see the odd 3s within the odd 9s. We can do all the numbers, do wheels for all the numbers. That make the children make them beautifully, and you can put them on the wall. They can become works of art, and the children will be just doing their multiply and divide by looking at their wheels on the wall. So this is a very subtle way of practicing multiply and divide and getting used to remainders and bringing in remainders as not as an exception, but as a natural part of multiplication and division. Whereas at school, we're taught the multiply tables and remainders are put aside for later. But I think remainders should be included right from the word go, because if I have 12 lollies to share with 9 children, we're going to get some left over. Everybody will get one, but there'll be 3 left over. Remainders are a natural part of life. So have fun with your number wheels.